Assalamu alaikum viewers. Today I will discuss about cooling water system. So normally every plant have cooling water. Where is use cooling water? So cooling water normally use condenser, cooler, heat exchanger for cooling purpose. So normally two types of cooling towers are available. One is called induced draft cooling tower, another is called forced draft cooling tower. So main purpose of the cooling tower, cool the water. I will try to explain details about cooling water system because in cooling water also require treatment. How many types of problem in cooling water? So cooling water also have many problems. Normally 4 types of problems are available in cooling water system. So one is corrosion, scaling, third is fouling, fourth is microbiological growth. So in this cooling tower, if this problem happen, what types of action are required, I will explain in my topics. In the cooling tower, 4 types of impurities are available. So these impurities also need to reduce. So normally in the cooling water system are available dissolved impurities, undissolved impurities, and gaseous impurities and others. Others means in the cooling water available oil, grease, acid, microorganism, bacteria are available also. In the dissolved impurities you can say different types of salt, calcium salt, magnesium salt, calcium sulfate, magnesium sulfate, calcium, sodium sulfate, magnesium carbonate. Like this salt are available in cooling tower. If dissolved salt are available, it will create scaling. If like this water provide on the condenser or tube or the line, it is accumulated on the tube, what will happen? This tube will be blocked. So water will not flow. So that's why these impurities also need to remove. Number 2 impurities is, I told you, undissolved solid. So undissolved solid like this mud, sedimentation and sand. These are undissolved solid. Third number is dissolved gases. In the cooling water system, dissolved gases are also available. So in the dissolved gases, you can say oxygen. Oxygen are present in cooling water as a dissolved gases. Carbon dioxide. If dissolved gases are available in the cooling water system, specifically if oxygen are available in the cooling water system, what will happen? It will oxidize. Oxygen and carbon dioxide, these are also harmful for the tube and for the flow line. The fourth number is others. Others means in the water present some oil, some acid, some microorganisms. So all impurities need to remove before using the cooling water. So viewers, now I will try to explain by a diagram. Maybe it will be easier for all. This is the blue down line. I told this blue down, okay. And this is the drift eliminator, okay. This is the header. This is cooling water header, and this is nozzle. Water come down by this fling. This is the makeup water line. Makeup water line, circulation pump, and this is the condenser. So okay viewers, you think this is the cooling tower system. So cooling tower system, this cooling water circulated. So first time I will explain about this cooling tower system shortly. So you think cooling water flow discharge from this pump from cooling tower basin, it is called basin. From this cooling tower basin and some, this cooling water discharge going condenser, it can go cooler. So you think it is going condenser. So after passes condenser, this temperature will be increase. Why it will increase? Because in this condenser, hot fluid will provided. So after counter contact, this cooling water temperature will be increased. If you think, if this cooling water temperature 25 degrees centigrade, after discharging from the condenser, it will increase. In our plant, it will now showing 32 degrees centigrade. In our plant now 32 degrees centigrade. After passes by this condenser, this cooling water temperature will be increased up to 32 degrees centigrade. So how much temperature difference? So temperature difference around 7 degrees centigrade. We are providing 3000 flow. So 3000 flow, 25 degrees centigrade temperature, 5 kg pressure, this flow will passes the condenser, will go to the condenser, and after passes the condenser, flow will be around same and temperature will be increased up to 32 degree centigrade, 25 to 32, around 7 degrees centigrade temperature increase. So this high temperature, for reducing the high temperature, we are providing this cooling tower. In this cooling tower, we are reducing temperature. How we are reducing this? Now I will explain. You think this 3000 flow coming on the header. This is cooling water header. After coming header, this set nozzle are available. So when this water flow will passes by this nozzle, this water surface will be increased. So after increasing this water surface, it will come down on the filling. So if it will passes by the filling, this velocity will decrease. Like this, is natural air are available. So here is natural air available, natural air. So natural air in this cooling water top side providing exhaust fan. I am explaining about induced draft cooling tower and forced draft cooling tower function almost are same. Induced draft cooling tower, this air it will take by this, it will suck the air and release the atmosphere. Induced draft cooling tower and forced draft cooling tower, main difference, induced draft cooling tower air taking by sucking, the forced draft cooling tower air providing from downside and it will go to the atmosphere. This is the main difference. So today I am discussing about induced draft cross flow cooling tower. After condenser, when water pass from the header, here is available nozzle. When passes from the nozzle, this water surface will be increased. After this water will come down on the filling. This filling also like this small hole. When it will come down by the filling, that time this water velocity also decrease. And here is fan available. This fan always suck the air. So air coming from atmosphere, this atmosphere air passes from this filling. So water passes from this filling from top to bottom side, and atmospheric air passes bottom to top side by this filling. So this air velocity also reduce. By this way, this air and water will come contact. By contacting air and water, this temperature will be reduced, because air temperature less than the hot water temperature. That's why by counter contact, this cooling water temperature will be reduced. So this side water passes and from this side water going. So this side counter contact. After counter contact, this air will go out where? Atmosphere. When this water and air counter contact, some evaporate. This evaporate vapor will pass to the atmosphere, but from this vapor possible to go some water droplet. So if some water droplet passes from the cooling tower, that time this water level will come down. For controlling this water droplet, we are providing here a drift eliminator. When this vapor with water go to the drift eliminator, only vapor will passes, but water droplet cannot pass. So that's why water droplet again come down on the basin. By this way we can minimize our losses. In this cooling tower, continue water is evaporated. So for evaporating this water, some water losses, it is called evaporation loss. So in the cooling tower, one loss is called evaporation loss. Another loss is drift loss. How many losses is in cooling tower? So now I will explain how many losses in the cooling tower. So normally cooling tower, first loss is evaporation lost, because this hot water and from here air, hot water coming contact with air, after contacting some evaporation happen. So this evaporate go to the atmosphere. So that's why some water will be lost. So it is called evaporation loss. So first loss is evaporation lost. A second one, drift loss. But when this vapor passes by the drift, that time possible to some droplet passes from the drift eliminator. Some industries drift eliminator not provided. If drift eliminator not provided, more quantity of water will be passes from the drift eliminator. Eliminator provide on the cooling water cooling tower, that time minimum water will be passes. So it is very negligible. When 0.1 to 0.3% water will be passes if drift eliminator provided. If drift eliminator not provided, that time possible to water passes 0.3 to 1%. So it is very negligible. So second loss is drift loss. So another loss also happen in cooling tower. This loss is blow down loss. So why this blow down required? So I will explain one by one, because normally in this water impurities also available, but if pure water evaporate and some impurities again added on the basin, that time what will happen here? Impurities will be increased. So if impurities increase and this water provide on the plant, this tube or line will be damaged. For controlling the impurities, we are doing this blow down. Third number is blow down losses. In the cooling tower, three types of losses are available. First number is evaporation loss, second is drift loss, and the third number is blow down loss.